And now it's time for the latest exciting episode of Doz's Television Workshop.
Hello and welcome back to Doz's Television Workshop, where today we're going to be having a look at this vintage, allegedly 405 line TV camera that followed me home from Retrotech late last year. Let's get into it. Right, here we have it, a vintage sort of CCTV type camera. It's not got a brand on it as far as I'm aware. On the rear here we've got a simple power switch. We've got a small bulging type input there. We've got a voltage selector, locking in, which is for sync, I would imagine, video output. We've got a simple cover. Warning notice on the top, disconnect the supply before removing cover. I should be ignoring that later. On the front we have a, what do we got? A Dallmeyer brand of lens. We've got possibly the tube position, I should think, and the actual optical focus itself. The lens looks horribly filthy. Yeah, this was sold to me at Retrotech. I didn't pay much money for it, so that's good. What bothers me slightly is if this is 405 lines, it says on the bottom here on this piece of tape, okay, 11/4/74, and somebody's squiggle. Well, if this is 1974, it's a bit late in the game for 405 line, isn't it? Unless it was made by a ham or something for some specific application. Looks quite well made, looks professional. I think the first thing we need to do is fetch out these 4 screws and see what we've got inside. Let me get my parts tray out. Oh dear. Dozens of resistors from when I was doing that HF record player the other week. We shall sort those out later. So we've got a machine threaded screw. It's stainless as well because it's not sticking to the magnet in the tray. It could be brass, couldn't it? Right, well that's our cover unscrewed. What lies beneath? Good Lord. Well, it is indeed a commercial piece of equipment. There's a wonderful smell of something coming off. And that does look to me to be, yeah, it's all semiconductor, and there's not a valve in there. However, these boards look slightly familiar to me, and I wonder if this is actually a Pi camera that's been boxed for some other application. So just looking around, I don't suppose you can see that capacitor there, but let me zoom in on that, and we'll zoom out a bit so it focuses. There we go. You can see there's a bulge in that. We've got a set HT pot down here. Is that target? That's target. That's the target voltage, or is it target current? Don't know enough about tube cameras. Beam, electrical focus, vertical shift. What have we got on the other side? More capacitors that have failed or failing. Yeah. A little daughter board on top of there. Ooh, there's a very crusty capacitor under there. We're going to have our work cut out with this one, aren't we? What do we got here? Line frequency, so our oscillator is on here. Field lock, gain, sync amp, and lift. So that's gamma correction's the wrong word, isn't it? Not quite sure of the word I'm looking for, but that lifts one of the levels. We've got a big power transistor on the back. And we've also got another very unfortunate looking transistor, the capacitor in the bottom of there, big one. This board looks to be plugged in, this one that's running this way. So yeah, I think I fancy starting there. I think there's a Weimer 0.22, that'll be a brilliant capacitors they are, they never fail. Still available today. But yeah, so at least it's not full of wax capacitors, I suppose, so we've got half a chance. And if as I think if this is actually a copy or actually a Pi Lynx camera maybe, then it wouldn't surprise me that it is actually 405 line. And I think they were modifiable even for 405 line work. But yeah. Right, where am I going to start? I think I'm going to start by unplugging this board here. I'm certainly not going to put any power straight on here. I can see several capacitors that are bulging all over the place. And yeah, I don't want to damage anything. So I think a complete recap is in order. It's a fair amount of work. Right, this nut on the back of this board, there's the screw, the nut isn't captive. What a pain. Just hook that out of there. There we go. I'm just going to put those back together so I know they sort of live together. Let me pull this board out. I shouldn't think this has been on in many years, so there's absolutely no danger of any charge remaining. It would appear the plug board doesn't clear the chassis, or it might do. Just about. Oh, you know what? I could have undone those two screws, couldn't I? That's probably why that board isn't doesn't have captive nuts on the back. It's because this chassis is tapped there. Zoom back out again. There we go. So you can see what's going on. Yeah. Silly Billy, needn't have bothered. Okay, we shall attach that board back to there. There we go. Set 600 volts. It's a C101-1 issue 5 board. We've only got one electrolytic on there. So maybe it looks a bit crusty. I can see some green on there. Let's get the old ESR meter out and not have to change anything we don't. Because I don't know if this is going to give me what I want. Anyway, so we will just probe on there and see what that looks like. 158.3, and it's supposed to be 125, and that's all right. Very low ESR. Well, I'm just going to put that back together, I think. In fact, I'm going to leave it out for now because I'm going to get that edge connector, a little squib of Deoxit. I can see what I have just spotted right in the bottom of the case here. If I can get in there, there's a lock washer. We don't want that floating around in there. It's obviously been stored somewhere damp. If I just get it somewhere in and we zoom in again, you can just see the corrosion on those screws in there. That's not so good. Right. What am I going to do next? I think I ought to work out how this thing actually sort of comes apart rather than pulling stuff out willy-nilly. So there's a board above our camera tube. By the way, you can see the camera tube socket in the back there. There's definitely some corrosion on the rear of these boards. So I think maybe I'll start on this board here. So that standoff has got to come out. I'm wondering if these bolt boards sort of fold out for servicing. Drop that. there. That one's clearly got to come away. And we've got some wires just soldered onto tags there. So let's just desolder those. We've had some replacement transistors in times gone by the look of it. And there is a little banana plug in there. I bet that's for the output. Yeah, we can see it's had a little bit of work maybe before. Typical 60s, 70s layout of hand-drawn PCB. And you can see all the sort of mould in the bottom of here. Right. Can I just fold that out like that? I think I can. Right, so I think we just bleep. It's almost like got varnish on this end. That's strange. I wonder if that's a little bit high voltage maybe. I think I just beep my way around these capacitors. I'm going to switch to my ultra zooming in glasses so I can read them. What have we got? Difficult to say with any certainty there. Well, that looks all right, that one. I don't know if you can pick that up on the camera. Let me zoom out a little bit. Can you see this end of the board is a lot shinier? I wonder if that's a quite a high impedance, high voltage connection. Although this is the line oscillator here. Maybe this is the first part of the vision amplifier because that's just where the thing connected. So that there appears to be faulty C4. What I'm just going to do is I'm going to sweat it out from this end and we'll measure it again. Well, that's one end lifted. Let's just try it again. Let's try and swing the camera out a little bit so you can see what I'm actually doing. Bear with me. There we go. Okay, let's just probe in there. Okay, measures okay out of circuit. There we are. Right, so that's a little group there, which appears to be okay. This looks like it's been moved before. Okay. So I'm just going to mark these with a Sharpie as I go around to see which ones are possibly bad. So I'm going to put a little tick on them, just on the one end. They're marked polarity wise on the board because I'm marking the plus end with a black stripe, which is possibly careless. Okay, C16. Okay, we've got a few to take apart and have a look at on this board. So what I'm going to do is I'm just going to lift each one and then quickly buzz around them. Right. Okay, so it's the following day because I keep being interrupted. But all I've got to do now, for this board at least, we're going to have to repeat this process for the whole thing, is to pop the capacitors out that failed on our peak tester, test them and replace them as required. Right, this calls for a bit of a time-lapse thing.
Oh dear, I just realised I got wires out here. Have I done that? Have I torn those off something? Oh dear. That could be bad news if we can't find a schematic for this. So, well, we'll work it out one way or the other. These big capacitors, by the way, are very difficult to put back in the board. The legs are so fat and the holes are so small that they're very difficult to get in place. There's another green wire being cut right down here in the loom. That one there, but that looks cut to me rather than broken. Oh, and look, it matches up with that one. Interesting. Oh, got that one back in perfectly that time. Right, solder him up. So that's all the caps checked on that board. What have we replaced? 1, 2, 3, 4 out of all of those. It's not bad, is it? That doesn't mean to say these haven't got other issues or have not much life left or have thermal issues, so when they get warm they start to fail. But the ESR gives us a good indication of the capacitor's health. So yeah, I want to move on to sort of the power supply. Let's just stop for a minute. I'm going to Google and see if we can find out what this camera is. This does sort of look very Pi to me. So I'm going to stop and have a quick look. So I Googled and got nowhere. And then I posted on radios-tv.co.uk and in their forum and asked if anybody knew what it was. Mike straight away come back to me saying it's a Link 101. And sure enough, on the tvcameramuseum.org, I have to say, I've spent a while poking around that website and it's fascinating. And here it is, European and American television cameras. It's a Link 101 and it does 62550, 40550 or 52560. So there we go, 1969 dated. Well, that sort of corresponds to our date on the bottom. And it was still available in 77, so it had a fairly good innings. Now, there was a guy called Brian Cuff, I believe, who actually assembled these. He's sadly no longer with us, but he remembers assembling these from sort of 68 and on. So there we go. Right, I'm now going to have to... sadly, this picture just doesn't have the resolution if I zoom in down to see where these wires I've broken off are down here. So I'm going to sit back for a minute and review that footage and see if I can see where they connect to. Right, well, I've zoomed in on a bit of footage and sure enough you can see this wire here is in fact cut. But this one appears to run up here and solder onto that. Now it doesn't entirely look soldered, but if you look at the pin, that is in fact wrapped around there and soldered on there. So our green wire joins up to this tag here and the grey wire does indeed go to our socket over there. So yeah, that saves the day. Well, thankfully I had that footage and it did enable me to work out that that's the green wire. I've soldered that back on there and the grey wire goes to our SO239 video output socket on the rear. And if you're thinking SO239, there's an odd choice for a video socket. It was quite common. In fact, the early VHS machines even had those on the back. So yeah, 75 ohm though, not your ordinary 50 ohm CB radio, but I'm sure you'll get away with 50 ohm connector if you have to. In fact, I intend to later on. So yeah, right, so now all I've got to do is just refit this board back into the camera, being careful not to break any more of those wires. So first off I need to refit this power transistor to the rear. Right, fact, this green wire, I wonder if it's the same as that green wire that sort of goes to this mod board here. Could be, couldn't it? Either which way. We're in reasonable shape now. Now for the next thing, I think I want to sort of get at that big electrolytic down in here. I'm not quite sure how to get at that really. I think we may need to hinge this sort of panel out of here, and I notice we've got connections at both ends, so that might be a little bit tricky in there. Let me spin that round so you can see. Got a screw missing again, some corrosion to that screw there, but we've got this red and black lead here, so I think probably one of the first one thing I haven't done is reconnect that plug to the back of that board in there. That was careless. Oh, I think I can just get that. I've got to get that board out anyway, because there are some very grotty capacitors on there, so I mustn't forget to plug that back into there. I wonder if I can just get in there actually and do that. Certainly if I slacken this end of the board off, I may be able to. Yay! Excellent. Right. The other thing I need to discuss is there was an email on the television camera website that talks about this, a slot-in panel. There was actually an email from the late great Brian Cuff that said this was a Ferox cube, and unbelievably these round things here were called Ferox cubes. They were available very easily, and it was sort of ferrite material that you could make inductors from. Quite useful things actually, and transformers and stuff. And this is sort of like a ringing switch, not quite switch mode as such because there's no real feedback to it. It's a ringing inductor sort of power supply that develops to 600 volts, and that's because this tube is used in, I think they called it 600 volt grid mesh mode, that enabled the tube to produce a better quality picture. So in fact, Mike, who identified the camera, said they were used when he was working in broadcast on the, I think he called it the overlay trolley. So producing graphic overlays, they used them in Genlock mode, which I suspect is all to do with that green wire. Because I notice up here in this loom, that green wire actually goes down to the cut end down there, and it says no connection on the back here. But I suspect that's where you put in maybe some sync for Genlock or whatever before this camera had these modifications made. I'm only guessing, but hey, we shall see. Right. Yeah. So also you can see, by the way, that knob on the front, underneath the focus knob, does in fact move the tube forward and backwards on a sled in the bottom there. You can see that top camera maybe. But yeah, so quite a thing. So where was I? Yes, removing this black and red lead. So pin 21 is the top one, and that's black. So Link Electronics are in Andover apparently, and oh, there's a blue and a yellow there. So what pins are those? 18. They're both pin 18. Probably a smudge on the silk screen there, but the blue one is the upper one. As I say, it's very nicely made. Also, there's a green lead again, another green lead. You can see it's got a sleeve on it there, and it's been fairly poorly soldered onto pin 22 there. Another pin 22. We could really do with a schematic at some stage. That in the pot, and very gently this time hinge this board out the way. Oh, it doesn't look like I needed to desolder those two either. That disappears off to the tube, presumably to the scan coils maybe. And ooh, this capacitor is in rotten condition. We've got a bubble showing at one end. I don't know how you can see that, because you probably can't You probably can on this camera. Let's have a little zoom in there. Yeah, you can see it's bubbling. It's very corroded. So I think what I'm going to do is attempt to slacken this nut off here, with a pair of pliers or something, ease that capacitor out of its mount, see what it is, and I think we'll probably end up ordering a replacement for that, but yeah. Right, looking in stock, I've got a brand fire new Kemet, 40 volt, and it is 4,700. So that's, look at the size difference, never ceases to amaze me. But it's got 3 tangs on the top, but it's only one under the negative on there that are connected. Now, I've had this in stock a little while, so what I'm just going to do is I'm going to hook it up to the power supply for a few minutes, limit the current, make sure it reforms all right. So yeah, just going to do that. Okay, that's that hooked up. I've got the power supply on. Now I can't get to 40 volts with this power supply, but I can get a 31, which is close enough. I've got the current limit on absolute minimum. So there we go. It's started charging. I'm going to go off for a cup of tea and return in a few minutes. Right, well, that reformed perfectly, as expected. I've 3D printed a little adapter so I can put it in the hole where the other capacitor came from. Like that, with a bit of luck. Might just have to undo that nut a shade more. Excellent. Right, see how the state of the wiring is under here. Solder that on. Right, that's that capacitor finally replaced. Let's just remove all this rubbish from here. And start having a look at this board. First things first, I actually want to reconnect these 2 wires that I didn't need to desolder earlier. You can notice on this board up here, let me have a zoom in, there are some very small fuses. Now those are not the usual sort of 25mm fuses. They're much smaller, and I believe they're referred to as clock fuses, but if one of those fails we can just fit a 25mm in there. Right, I'm just going to have a run around with the ESR meter. All the capacitors on this board do look physically in very good shape, with the exception of this one here, I think. We will just run around them all. In circuit a leaky. $443 mic, and it's supposed to be 400, so that's passed. Yep, that one's good. This one's 125 mic. In circuit a leaky. Let's use the red Sharpie to mark up the ones we've got to take out and check. Suspect. It's good. Suspect. Suspect. Right, let's get those out and get them checked. So, out of this sort of second PCB we've inspected, again, only 2 parts out of spec. It's really built with some high quality parts. So yeah, I'm just going to inspect this flyback sort of converter board here as the next job. That needs to come around there. It's definitely been apart before this thing, but yeah. So this is so-called ringing oscillator that makes the 600 volts. You can see on there it's a set 600 volts. So let's just check these. 158 mic, yeah, well that's to spec. ESR is very low. End circuit or Lisi, ESR 6.9 ohms. Again, that's one of those 4.7 mic capacitor things. Right, I'm just going to get a little splodger deoxit on here, and maybe a little bit of the old magic eraser just to clean that up. Yeah, let's clean that up nicely. So I'm just going to get on this edge connector as well, which you probably can't see. Let's widen the old angle out. There we go. So the edge connector it sits in is down there. So not a good connection in there. And then we have to reassemble this. And we need to remember which way round it goes. So that fits in like that. Right, the rear of this board had some bizarre corrosion on it there, so I think we'll just get a bit of cleaner on there and just try and scrub that away. There's actually a joint there underneath that looks pretty suspect to me. So I'm just going to touch that up. Is that there? Doesn't look ideal. That's more like it. Right. So I think we can refit this board, and we've got to reattach that in a minute. So put the board back in its slot. Caught up on our new capacitor wiring down there. I'll just hook that out of the way. These two wires here need reconnecting. Right, just that top board to check, and I can already see. Let me zoom in. Yeah, there you go, you can see that now. You can already see this capacitor is leaking everywhere. Not sure about that one. The rest of them look alright, except for that one on the end there. So we'll be changing those two regardless. But we'll just have a whiz round with the ESR meter again. Not so sure about that one there, but let's listen for the bings, let's see where we get to. Ah, so we have a shielding plate underneath the board. Okay, so we're going to need to remove those nuts, I suppose. There we go. It's time to put some power on. Now, what I'm going to do, I'll just talk you through this. I'm going to fire up my oscilloscope because I haven't got a monitor handy if this does turn out to be 405 lines. We're going to monitor the video output, and then we're just going to cover the lens up, and we should see the waveform change. And if we measure the line rate, the pulse repetition frequency between the line pulses, if it's 10.125 kilohertz, this is a 405 line camera, and we should also see positive video modulation. So as the picture gets brighter, the waveform should increase in voltage. If it's 625, the repetition frequency will be 15.625 kilohertz, and the video modulation will be upside down. So dark will be a bright or higher voltage waveform, because it's negative video modulation. Right, I'm going to sort that out. You stay there, I'll be back in a second. Okay, so I've got power connected to the lamp limiter to the Variac, and that's going in dodgily on these two plugs here. Not ideal. The oscilloscope is connected up, and the camera's running on that. So, without further ado, main switch is on. Main switch is on. Let us gently bring up some power whilst monitoring the current draw. 83 volts, and our oscilloscope has gone off range straight away. Oh, right, okay. Okay, we've got a negative voltage on our. Let's take it up a bit more. There's 100 volts. We are drawing a little current. Can't hear anything. We're at 185 volts. So that's at 200 volts. I haven't got anything glowing on the lamps. We've got an indicator lamp on the back. Let's see if we start to get anything on our camera. Let's just improve the... Are those line pulses we can see there? Let's edge it up a bit more, shall we? So that is 230 volts. We're consuming 120 milliamps, and we've definitely got pulses there, haven't we? Let's see if we can lock onto those a little bit. Trigger level. Okay, let's increase our voltage per division. Those are definitely looking something like sync pulses. But they're at 1.8 kilohertz, well that doesn't make much in the way of sense. Let's bring the waveform up a bit and see if we get a trigger on it again. Let's go to measure. I don't want to measure. We've got a volt peak to peak, so that's a start. Channel 1 measure type. Frequency. 9.4 kilohertz, so it could well be a 405 line camera. And have I got some semblance of video response from it? Oh, I have, I think. Oh, it all seems to be sat there behaving itself. There's a bit of hum on there, isn't there? Let's turn that trigger back up again. So 9.57 kilohertz. That might be near enough to get a television set to lock. There is a line frequency pot on here somewhere, I did see it. So I wonder if I just give that a little tweak. Is it on this side or is it on the other? I think that's all the tube things. Yeah, line frequency, it's down here. I have to say I can't hear anything running. Oh, 11, 10, a little bit more maybe. 10.2, just a shade over. 10.12, I saw it. Okay, so we've got a 405 line rate coming out. So that's quite exciting. Now I suppose the next thing to do is go and get a TV set. Now I need a 405 line monitor, which I don't have, but I do have a Sony 990, which is a dual standard 405/625 set, little 9-inch black and white thing. and it does a trick because you can fudge it to receive 405 line signals at UHF. So I have a UHF modulator, so I can plug the camera into the modulator, connect the modulator to the UHF input of the 990, fudge it so it receives on channel 36, whatever channel I select, and well, that should work. Let's try that, see if we get a picture out of it. Right, stopping there. Right, this is the setup I've got. So the Sony 990 here is currently set to UHF. It's currently tuned into channel 35. You can see the test bars there, and that's coming from my modulator in test mode. And if I push these two buttons in together, we should go into 405 line mode where we can't get line sync. So that's working. I'm just going to switch the test beacon off. So now we have a blank raster. I've got the camera pointing at the 990 instruction book. So let's apply some power, click on, and yeah, we appear to have got quite a bit of hum there. So yeah, maybe we've got something wrong with the shielding or something, not quite sure. But let's see if we get an image as the tube warms up. We've certainly got sync. A precious little in the way of modulation there. Let's ease the tube back. Now we've got interesting issues. Okay, well, we have got a stable line structure. But we don't really have any image at all, do we? So let me just try and... I don't know whether this lens even has an aperture. Oh, it does. So let's try and... Oh, it's ever so stiff. I don't know what these numbers on here mean. Presumably a bigger number is more aperture is exposed. Let me try and wind that up. Oh, it's easing. It is easing. Just got a precious little image though, have we? Well, we've sort of got a locked frame, so that's something. Let's give the old beam current a bit of a tweak. Height, no. Focus, vertical shift. Well, perhaps our focus is so far out, you'd still think you'd see something. No, just that black bar on the screen. Target voltage. Now, when I used to play with these as a kid, I used to remember that made quite a wild difference to where you could get a picture and where you couldn't. No, we don't appear to have anything. Well, this is our beam here. It's entirely possible our tube is duff. I tell you what I'm just going to do. I'm just going to switch the light off here for a second. So I don't see any heaters in there, and I can't. Okay, so presumably we should have some heater volts on there that we're not getting. Right, let's just switch off for a second and see if I can find a pinout for the tube. Now, on that data sheet I pulled up earlier, it did tell you the type of tube, so that might be useful. I'm going to go and examine that. Right. So I measured the heater volts because I couldn't see any glow, and sure enough we got 5.9 volts, which is near as damn it to 6.3 that we should be seeing a glow, I'd have thought. And then I thought, hang on, right, so I've removed the base. I put my meter on those two pins because they should read, you know, not a lot of ohms, and they're completely open circuit. So our tube is cooked. I suspect what happened is it's possible it went down to air, it's had a knock in its life and it's gone down to air, and next time somebody went to switch it on it just burned it straight out, which is what happens. Yeah, that's grim news. So if you have a Vidicon, a 6977 Vidicon kicking around in your shed, garage or workshop, drop me a line, I'd love to hear from you. I've measured all the voltages on the other pins and compared them to the datasheet, and they're all in the right ballpark. So sadly, if we had a good tube, I think we'd get a picture. But just for now, that's a bit grim. Never mind, we shall box it up, put it to one side, maybe one day we'll get a tube. Until then, click like, subscribe, do all that rubbish, and I'll see you very soon here on Doz's Television Workshop. Cheers now, bye.
Hello, and welcome back to Doz Television one last time. 5 lines that I got in retro at
And of course the front doorbell goes. Better get that. Back at a trice. Put them on the meter, and my mate Collins just advised me he's coming round, so I'm going to stop. Damn it. Cancel this scene. Voltages on all the other pins on the tube seem to be correct. So, rats. Never mind. We should put it to one side, and I will see you very soon here on Doz's Television Workshop. Click like, subscribe, do all that rubbish. Let's just do this whole last bit again, shall we? Sadly going to end. So, yeah, it's another fail. Never mind, we've had a good run, right? Do it one last time. Disappointing, to say the least. Meh.